Hi, good afternoon, everybody. Apologies for starting a bit late, but thank you for joining us today on our webinar on deep retrofit. As an introduction, my name is Joanna O'Loan, and I'm the Knowledge Manager here at the Energy Saving Trust. Just a bit of a background to our webinars. Over the past few years, we've been delivering webinars covering a wide range of different aspects to renewables and the domestic energy sector. This area of work is funded by the Scottish Government as part of their support for home renewables and energy efficiency, and that's all there to kind of meet our climate change targets and also support kind of Scottish households lower their energy bills in conjunction with that, all contributing towards building our kind of lower carbon economy. Before we begin with the webinar, I've got a couple of housekeeping things just to quickly run through. Those of you that are regular attendees of our webinar, this will all be familiar to you, but just in case anybody's new, a couple of kind of general housekeeping points. You can hear us, but we can't hear you. This is maybe particularly an important factor now that we're all, or at least most of us, all working from home and school's closed, so I'm aware there might be kind of kids playing in the background. So don't worry about any background noise. We won't be able to hear you at all, and hopefully you can hear us all okay. However, if you do want to get in touch with us, you should now see, I think somewhere on the right hand side of your screen, you'll see our webinar control panel, and within that there's a space there for you to be able to type any questions you have. We'll do a kind of short question and answer session towards the end of today's presentation. Equally, you can use that box as well to alert us to any technical issues you might be experiencing. Nobody else in the audience, so none of the other listeners, will be able to read what you're writing, but whilst the presentation is going on, kind of I'll monitor that, and kind of if there's any technical issues, I can sort them out there. Otherwise, we'll keep a note of your questions and address them at the end. Finally, just that this webinar is scheduled to last approximately an hour. We'll be recording the session as well, so if you need to leave us early for any reason, I'm aware we're starting a bit late, so if you do need to leave, don't worry, just kind of drop out, and we'll circulate that link to go around after. And equally, if you know kind of colleagues or anyone else that might be interested in what we're chatting about today, you can kind of pass that link along for them to be able to watch at a more suitable time. So I will introduce today's speakers, but just quickly before I do that, I'm aware we've got quite a mixed audience today, so I just want to make sure that we are all aware what deep retrofit is. So just start. So yeah, deep retrofit in Scotland. What do we mean by deep retrofit? Deep retrofit's aim is really to take an existing building and reduce its energy demand or carbon emissions, depending on kind of your ambition, but to really reduce that to the lowest possible for that building. Why is it important that we're doing that to our existing buildings? Well, the majority of the housing stock that currently exists will be the majority of the housing stock that we have in 2045. Whilst new buildings are going up all the time, what we've currently got is going to be the most of our housing stock in the future. And so if we are going to achieve net zero by 2045, we really need to look at that existing housing stock and reduce that energy demand in order to help us achieve that. Kind of going back to that first point though, where we mentioned about how taking the energy demand kind of low as possible, and what do we mean by possible, and that's really what we're trying to get at with when we're talking about deep retrofit. So deep retrofit is really defined by this, what's termed kind of the whole house approach, and really what that's trying to define is a much more sustainable approach than has maybe been considered previously. What it aims to do is have a look at your selected building in its kind of entire envelope. So looking at how the building behaves, all the functions that building performs, and the aim of kind of approaching a retrofit project like this is to reduce the risk of unintended consequences that can sometimes arise when maybe you focus too purely on energy efficiency. So maybe historically, when there's been huge ambition to improve the insulation of a property, what we've seen is that's maybe been to the detriment of the property's ventilation, and that can cause quite serious damage to the property, and we've seen that happen in the real world, as it were. But beyond just kind of also looking at the building physics of the property, it's also important to consider how the occupants behave in that building. And whilst we all live quite differently, and trying to kind of incorporate that when we're planning a retrofit project. So really taking whole house as broad kind of a definition as you can in your approach. And that's what we mean by possible. It's really having a look at what that building function is in terms of its contribution to its community, how it looks. All these things are the aesthetics of the property. All these things are really important. How do the occupants of that building behave when they're in that property? How do they heat? How do they use the building? And then obviously all the physics of that building. So that's when things like insulation, ventilation need to be considered, indoor air quality, acoustics, all sorts of things kind of come into play, lighting, all sorts of things kind of come into play, and it's really trying to think about as many of those things when you're pulling together a plan for retrofitting your property, all whilst with that overarching aim of energy demand. So it's a enormous feat, and in some properties it's something that maybe is more possible than in other properties, but really this is kind of a category of work that really needs to be considered, considering the very ambitious target set by Scottish Government of net zero by 2045. This is something that really urgently needs our attention, which is why I'm really delighted to have the speakers we have today for you. I'll give a kind of brief introduction to them both, and then we'll have a kind of question and answer session at the end of both of their presentations. So our first speaker today is Barbara from John Gilbert Architects. She leads on their Hab Lab consultancy service, and within that they kind of coordinate building performance evaluation and deep retrofit consultancy services. So exactly kind of the next steps of what you would be doing here today. She will be talking about that Hab Lab service in a bit more detail about what they do. They are currently preparing a whole house retrofit design guidance for Renfrewshire Council and their existing cross walls housing stock. So yeah, that Renfrewshire Council project's been awarded funds from the Department of Business, Energy and Industrial Strategy, or BEIS, through their whole house retrofit competition. And it's a fantastic project, delivering a Fabric First retrofit programme to, I think it's 75 properties in 3 different areas located in and around Paisley. So Barbara will be talking about that Cross Walls Properties project, their performance targets and compliance. And I think the aim is to refurbish them to Retrofit standards. So if you're not aware what Retrofit is, you might have heard of Passivhaus, so kind of really strict standards, but very, very low energy demand. And that's a kind of standard that's been adjusted for retrofit projects and termed Retrofit standards, because some of the qualities of Passivhaus would just be impossible in kind of all retrofit designs, because you've kind of got things that you can't change and can't adjust to make it possible to achieve Passivhaus. But by no means does that make Retrofit easy to achieve. It's definitely one of the most stringent standards available for deep energy retrofits. And so if I could quickly introduce our second speaker though. So following Barbara, will introduce Julio Bros-Williamson. So he is a lecturer in architectural technology and building performance at Edinburgh Napier University School of Engineering and the Built Environment. He's an architect graduate from the School of Architecture at Marista University in Mexico City, and holds an MSc in Energy Efficient Building from Oxford Brookes University. He's been a chartered Mexican architect since 2003, and he will chat to us today about a particular research project that he's been working on, kind of slightly outside of his work at Edinburgh Napier. He is also a director at the Scottish Ecological Design Association. So most recently he's been contributing towards the research section of the association, and responding to kind of government consultations and sourcing research funded projects. So really wonderful to have him and his expertise here to speak to us today. A bit about what he's going to chat to us through is a current research project, as I mentioned, looking at installing beaded insulation behind lath and plaster in tenement buildings in Scotland. So be fascinating to see the results of that and the findings of that research. It's could be beneficial to quite a wide number of properties in Scotland. So it'd be great to kind of learn a bit more about that project. And again, just before I hand over to Barbara, just to kind of remind everyone that I have started a bit late today, but the webinar is designed to last approximately an hour, so hopefully we'll have time at the end after both speakers are finished just to do a kind of short question and answer session. So Barbara, if you would like to begin.
Hello, Joanne, thanks very much. And hello, everyone. I'm also working from home now, so I hope everything goes well. So I'm going to talk about what we are doing in HabLab and what we've been doing in HabLab for the last 6 years. And I'm going to structure my presentation in 4 main sections. The first one, give you an introduction what our office does and what HabLab for the office means. Secondly, I'm going to give you a general context of the retrofit industry, what is it that we have been finding in our building performance evaluation consultancy projects. Thirdly, I'm going to briefly introduce you to the PAS 2035 standard. Many of you, well, some of you probably heard about it, but it's now a relevant standard for deep retrofit, and I'm briefly going to talk about it. And lastly, I'm going to go through the case study that Joanne just mentioned. So, Joanne, can you see actually my slides just to check?
Yes, we can, yeah.
Well, good, great. So this is us. This is John Gilbert Architects. And if we, so the office, it's 28 years old. We have the way of how we work. We don't have structured teams. We try to promote the transfer of knowledge as much as possible, and that's why I'm also I'm working 100% of my time in HabLab, that it's a building performance evaluation and retrofit service. And the way of how I'm doing it, it's I work in retrofit and consultancy projects, but I try to feed what I learn. So this is what we generally, so the office works on 4 main fields. First one is conservation, retrofit, strategy and master plans, and sustainable architecture. And the fourth one, it's HabLab. So HabLab is now 6 years old. We have been focusing in the evaluation of buildings and in how they really perform in practice and in use. And it's a way, what we see it as a new way of engaging with the industry, providing feedback loops not only to our office but to clients and the whole industry. So what we do, it's we try to make building performance evaluation accessible to the industry, because building performance evaluation has been there for many years, but it has been more limited to universities, which is great. But what we try to do is just to implement it and give it a commercial use and offer it to our different clients. Our methodology consists on 3 main stages. The first one is we evaluate building, we go on site, install sensors, and conduct thermography, conduct tests to understand how buildings perform in reality, and not only in how they, and to try to not only limit ourselves on theoretical models. On our second stage, we base retrofit recommendations on what we found on site, and this tests and evaluations that we conducted on the first stage. And on a third stage, we after we install the retrofit recommendations, we evaluate them again to understand how well they performed and to identify defects to improve the process for our next projects. In this slide, we are showing the kind of tests that we conduct on site. Broadly, they are grouped in 4 big groups. The first one is energy monitoring. Second one, it's indoor environmental quality. The third one, it's building and fabric measurements, and the fourth one, it's our contact with people. Some of this equipments are very accurate and expensive, but other ones are now accessible for most of our clients and not expensive at all, and can be installed to many houses. We have evaluated a wide range of houses and buildings in this last years, and I will try, with this slide, I will try to guide you through our main findings. So overall, the tests and evaluations that we conducted are many times were conducted on a building that had been recently retrofitted. So we have a good idea of how existing buildings perform and also how retrofit measures have been installed. So firstly, the retrofit works generally to reduce energy consumption, but not as much as predicted. And this shows that there is a huge unfulfilled potential that could be many times, that there are many small things that we will go through in the next slides and identify why this is happening. Secondly, in terms of comfort and human health, houses are a bit warmer and more airtight, but due to the retrofit works, but this also exacerbates health risks associated with indoor air pollution and moisture. And that happens mainly because retrofit projects are not designed holistically. And by saying this, I'm saying that this problem can be avoided. And these are problems generally related to condensation, mold growth, poor indoor air quality, and overheating. Thirdly, the construction quality, it's generally, not always, but generally poor. And this is mainly because details are based on standard solutions provided by manufacturers who not always understand the variety of buildings and the variety of climate conditions that these buildings can be in. And on top of that, there are roles that are generally missing in retrofit projects for inspection and professionals who could ensure this quality. For example, architects or clerk of works are usually not present in retrofit projects, and they are present in new build projects. In a fourth point, and this is a very important issue for us, we consider that people are the biggest variable in all aspects, and this variable are many times underestimated, and this means that retrofit works many times do not consider are focused many times in the technical issues, and retrofit works are not really linked to how people are going to use their homes or how they feel, or and this is for us a missed opportunity. So all the issues that I mentioned before, they can be summarized as what it's called it's generally called the performance gap. So this is mainly the gap between predicted and as-built performance. So all what has been specified in theory, all the sub calculations and how drawings have been prepared are not actually happening on site. And many studies have confirmed that this gap in the UK it's quite big and are creating many new problems. They're introducing new problems. So and previous studies, and this is not only based on our findings, this is based on many other studies that have been published in the UK, suggest that or confirm that this is the performance gap. It's due to a lack of understanding on how existing buildings actually work, and it's also due to wide. It's mainly due to the fact that I think it's basically what I was mentioning before, that the design solutions are based on standard details and are not bespoke solutions for each building type. There is an unclear allocation of responsibility and also an inadequate communication of information. There are a few examples that I'm showing on the right where the insulation hasn't been installed in a continuous way. It's stopping at rain pipes or down pipes and around windows, and that's creating this gaps in the insulation that leads to thermal bridging, and that it can be explained as concentrated heat loss, and that will be so it leads to mold growth internally. So just to give you a general context, and this is also what Joanne was mentioning before, there are several targets that the government has been setting for housing association and local authorities to meet. Some of them are more ambitious than others, but the important thing is that this highlights the importance of trying to minimize the performance gap and trying to to conduct retrofit as deep as possible. There are standards such as ISH 1 and ISH 2 that require that social housing needs to meet EPC Band B by December 2035, which is for many of our clients an ambitious target. And in the context of what what are requirements for retrofit and whatnot. Up to now, beside of building regulations, the only requirement was past 2030, which is linked to specific funding requirements, but there are not many retrofit standards for Scotland and in the UK for our clients to follow. So that's one of the challenging parts. Past 2035 intends to support many of these publications that highlight the performance gap, and that's why I'm going to talk about it in the next slides, because we think that it's a good guidance for deep retrofit works to happen and to minimize the performance gap. The office has also been involved in the Sustainable Renovation Guide that has been prepared by Chris Morgan for the Pebbles Trust, and I invite you to download it. I will give you the more details on where to download the guide, but it can be downloaded for free, and it gives you a wide range of retrofit recommendations for all the type of existing housing in Scotland. So we find it a really useful guide to for deep retrofit projects. So deep retrofit, as John was mentioning, it focuses in a whole house approach. That means it's holistic and it's not considering the building systems separately. The aim is to achieve an improvement in energy efficiency while ensuring that these measures work together successfully, future-proofing the property and ensuring comfortable living conditions. This approach considers that the building systems work as a whole and can be improved separately. Energy savings in average deep retrofit projects can range between 40 or 60%. So that means that a house will be 40 to 60% cheaper to run. What I was saying before, there are no clear or set performance target for Scottish deep retrofit right now. And they are international targets such as Retrofit, that is the Passivhaus retrofit standard. And I'm going to talk about it later because that's the case study that I'm going to describe in the following slides. In that context, past 2035 provides a specification and best practice guidance for energy retrofit works for domestic buildings in the UK. It has been released by the British Standards Institution in July 2019. So it's relatively new. Some funding schemes are already, it's already requirement for specific funding streams, for example, ECO, but it's not a compulsory standard right now for most of the retrofit projects. It provides a series of guidances on technical aspects and on the process in general, specifying the right retrofit measures in a holistic way, assessing the interaction between measures, assessing ventilation. That's not many times it's not being considered in retrofit works because it's generally only focused on energy efficiency aspects. Assigning a project manager, which is it's compulsory. It's compulsory if one wants to comply with past 2035, and that's the retrofit coordinator. It's the project manager of a retrofit project, ensuring appropriate qualifications and skills by providing trainings and qualifications, ensuring that monitoring and evaluation takes place before and after a retrofit project or retrofit measures are installed, And all of this helps to provide a feedback to the industry and to the different clients and parts of the industry. So until now, only past 2035 was a requirement for funding streams. And past 2035, probably most of you are familiar with this, but it's a standard that for the installation of retrofit measures. So until now, there wasn't really a general structure of how, or no suggestions of how the retrofit procedure had to take place. Now, with past 2035, this well, it basically incorporates, it absorbs past 2030, but gives a longer, gives a general guidance on how project has to be assessed in the first stages, how the design has to be developed for different building types. It advises the industry how to install it and how to monitor to make sure that the retrofit measures are installed in the right way. And the whole process intends to minimize the performance gap that we were mentioning before. So that's stage number 1, inception. Stage number 2, design, installation, and monitoring. So the standard basically covers those 4 stages of any retrofit project. Part of the inception and design stage is to assess and how risky a project is going to be, and that's linked to how many properties you're going to refurbish, what are the kind of measures that you're intending to install, what are the interactions of measures, and how old the building is. That will give you a specific type of risk that will establish how risky the project is, and depending how risky the project will be, will define how many considerations the designer or the retrofit coordinator needs to consider during the whole process, and how it will need to be monitored. So I'm going to go through one of our case studies now. I will try to keep it as short as possible, just to keep time. We keep the timing right. We are currently preparing best practice deep retrofit advice for Renfrewshire Council for most of their building stock. What you're seeing right now, it's some of a different building types that we've been preparing for which we have been preparing retrofit recommendations. One of them, it's cross walls houses or flats, but there are other types such as traditional sandstone tenements, BISF houses, and BISF adult steel, and so on. So one of them is the cross walls, and that's the case study that I'm going to go through right now. So for this particular project, well, something that I wanted to say before that, for all the projects, all of them are treated as deep retrofit projects, and all of them we've been implemented the 3 stages approach, where we are evaluating them first in the first stage. We're preparing the retrofit recommendations, installing them, and evaluating them after they're installed to make sure that they work as we are expecting them to work. For the cross walls, we actually use this project to enter a retrofit competition that has been run by the Department of Business, Energy and Industry Strategy, and we have won we've been awarded funding for 75 cross-wall houses that are located in Paisley. We've done this together with Renfrewshire Council, and our partners on this are also BRE, CSIC, and the Passivhaus Trust. So the property types, if you probably know this kind of houses, are from the 1960s. The energy reduction target for the deep retrofit project is 25 kilowatt hour per square meter per year, which is so probably for the ones who are familiar with those numbers, is a very low energy consumption. The general retrofit strategy is fabric first. That means that we are treating first the fabric and all the components that form the fabric, that is walls, insulating walls, roof, ground floors, windows and doors. And then after that has been improved, we follow the process by improving the building systems such as heating, ventilation and renewables. The cost benchmark is £55,000 per property. And well, I was mentioning before, it's a fabric first that includes timber cassette panels to the front, cavity wall insulation and external wall insulation where we currently have cavity brick walls. And we are also going to install solar PV panels and MVHR system an important aspect actually of the fabric improvement proposal is that we are going to improve the air tightness to very, very low levels, and by doing that we are improving the energy performance of the building, but to make sure that we are not introducing any moisture issues, we are installing mechanical ventilation with heat recovery systems to ensure comfort to the residents. This project intends to comply with PAS 2035 and intends to be a case study to implement this standard, and it also intends to comply with Retrofit, which is the Passivhaus standard for retrofit projects. And this standard looks to improve insulate and improve air tightness levels to very, very high standards to be able to reduce energy consumption as low as possible and not have to rely on building systems. So this slide basically summarizes what I was talking before and shows we have based on what we have evaluated on site, we selected 4 packages of measures to adapt the design solutions as much as possible or to base the design solutions, retrofit design solutions as much as possible to the existing conditions of the property. So actually, so I'm just skipping a slide to explain here that we have assessed first with thermography, air tightness testing, and energy modeling the existing conditions, and have based our retrofit recommendation on what we found. And you can see on the right some of the examples of what we've done. For example, air tightness test that proved that the building was leakier than average and that highlighted the importance of trying to tackle that issue more than others. In terms of past 2035, the assessment that I've mentioned before confirmed that the project it's a design path C risk, which required a more stringent design consideration than other type of projects. So more checks, more information provided by the retrofit designer and so on. The retrofit coordinator and designer it's John Gilbert Architects. I'm the retrofit coordinator for the project, and the retrofit designer it's one of the architects from our office. The retrofit evaluator was going to do the pre and post evaluation. It's BRE, and there is also an assigned retrofit advisor, that is the WISE group and Renfrewshire Council, that follows up the consultation with residents and occupancy service and so on. So our anticipated outcomes is that the proposed measures are going to improve the EPC from 54 to 91, which is really a huge improvement, and it will future-proof the properties to meet EASH not only 1 but EASH 2. So it future-proof the properties for the targets for 2032. The existing primary energy consumption of 330 kilowatt hours per year per square meter, it will be reduced to 25 kilowatt hours per year per square meter. So that means that that's a 92% reduction. We will start on site, hopefully, depending on the circumstances. It will start with a prototype on site in April 2020 to test how what's possible and what's not, and we're going to test this on a void property and start with the main contract of the remaining 74 properties in June 2020. And there is a whole series of a people engagement program that we are conducting with the council to make sure that this will actually happen, to minimize the performance gap and make sure that our specifications are actually going to be installed as expected. And this will be by carrying out toolbox talks, workshops, asking the residents what current issues are and what current comfort levels are. And we will also provide and prepare quick start guides to explain to the residents how to use the new systems. And I think that's all. I hope I didn't talk too much. You can see in the last slide my contact details. I'm happy to get any questions or if you have any specific question or query, please do contact me. And I'm also providing the link to where to download the sustainable renovation guide that the office and the Public Trust has prepared, along with CEDA and Historic Scotland. So that's me.
Thank you very much, Barbara. A really interesting, fascinating talk. Great to see kind of what your service offers and also kind of see it in practice in a real project. So thank you for sharing that. I will share around a link to the Sustainable Retrofit Guide along with the link to the webinar. Fantastic contributing authors towards that really useful resource to kind of anybody really thinking about retrofit, but a particular focus on Scotland. So wonderful to have that kind of freely available. So make sure that everybody gets a link to that as well to download. We will do a kind of short question and answer session at the end, but I'd quite like to make sure that we have plenty of time for Julio's presentation. So without much further ado, I'd like to welcome Julio if you're ready.
Thank you for the invitation to begin with. Yeah, my name is Julio Bros-Williamson. I am at Edinburgh Napier University, and I work also for the Scottish Energy Centre, which is within Edinburgh Napier. We do a great deal of building evaluations and also retrofit kind of scheme design and really support a lot of the work that maybe architects, developers, and material manufacturers are kind of developing. And that is relevant to the topic I'm going to be talking about today, which links in this idea of retrofitting solid sandstone walls and using the knowledge from a case study that I've been involved in over the past couple of months, nearly a year now, with a company called Energy Store. And this research has been funded by Construction Scotland Innovation Centre, and the kind of support they've given us is to interact and work alongside Energy Store to develop and to test some of the interventions that I'll be talking about. So I'll begin with just a kind of roundup of what I'll be talking about today. Just really a background on the project and some of the kind of drivers and reasons for engaging into this topic and this information and this project. I'll then move on to talk about specifically about the case studies and their location, etc. And then on to a kind of taster of the results. The report for all the results and a deeper understanding and analysis has just been handed over to Construction Scotland Innovation Centre and to Energy Store, so that will be public domain and available in the near future. So if anyone wants to dive into them in a bit more detail, they will be available. I'll give a taster of them just now. And then following to that, the impact and benefits of such work and linking in maybe to other projects and just how a system like this could kind of benefit and save a lot of energy and carbon emissions. So just a bit of a background on the work and what this entails. The project really focused on retrofitting existing walls in dwellings and looking at ways in which traditional solid walls with a cavity behind their dry lining, so typically your older properties with a lath and plaster traditional dry lining, or if they've gone through some retrofit in the past, some of them have been gutted out and new plasterboard kind of linings placed. Now, typically these would be, they would keep that cavity unfilled, and that was kind of the appetite to the project, to seeing ways in which and exploring ways in which we could fill that in and look at ways in how that would operate and work. Now the company Energy Store are leaders in the production of expanded polystyrene beads, as well as other products. And traditionally, they were really into supplying the beads for cavity insulation, masonry cavity insulation, amongst other uses. But the beads in this case were looked upon as an ideal product to inject behind these dry linings, these existing or plasterboard type dry linings. And particularly their product, their leading product, which is a super bead product, And it's this kind of grey coated polystyrene beads that a lot of us are probably familiar in some furnishing, bean bags, etc., packaging. But in this case, these have been thermally coated to produce and to act in a much more robust thermal response. Now, typically, as I mentioned, these are and they have been for many years now, been used to inject it into existing cavity masonry walls that hadn't been insulated previously. It's now, I would say, maybe 80 to 90% of masonry cavities are using these bonded beads. And moving forward from the earlier versions of foams and all these other kind of not very ethical and good performing in terms of humidity and the rest. So this has been kind of the leading product, but now Energy Store is exploring other ways in which it can be implemented. So really the issue that we need to tackle, and Barbara kind of touched on it slightly, is making sure that existing buildings are performing better and that we are able to reduce their environmental impact and look at ways in which they can be thermally comfortable as well. And this is because at least 64% of our energy demands are for space heating. We live in a country that has a long winter period, 7-8 months, and constantly people are choosing to obviously have their heating on during these periods. So it's vitally important to tackle this and to do it in a very efficient way. Now, a lot of your solid sandstone and solid walls are very typical here in Scotland. I mean, 60% of dwellings in Scotland were built before 1945, and certainly a great deal, 23% of that are pre-1919 tenement flats or solid sandstone buildings. Now, before 1919, a lot of this was this kind of barrier and timeline when construction evolved into having the cavity masonry walls, and previous to 1919, the majority of construction was done through solid walls. Hence, a great deal of the problems that we face in a lot of our existing buildings. So really, this project builds upon some of the trials that ourselves and other professionals, other universities formed coming up to 7 years ago with Historic Environment Scotland, in which we trialled and looked at various materials for the best options and the best and more efficient ways of retrofitting traditional buildings. And one of them was the trials around beads, polystyrene beads into cavities, just like in this project, as well as other products like aerogels and wood fibers, etc., etc. But sadly, those trials were limited. They were small in quantity, and really we did get some good response and good results from them. But we're only talking about 1 or 2 examples. So this project really builds on that, and I mean, a lot of the results and studies have been explained in a lot of the technical details and documentation that we produced together with Historic Environment Scotland on the results, on the techniques, and on the kind of benefits that these products bring to occupants and to the building. So really, I would encourage a lot of people attending today to download these and access them and get an understanding of how they're they're very useful for similar properties. So back to this project in terms of what we covered. So we looked at expanding and creating a larger evidence and to create a larger body of evidence on the use of these beads. And to achieve that, we were able to work obviously with Energy Store to provide the beads, but also a series of installers and principally Everwarm, who were great for obviously taking the product and dealing with some of the other stakeholders. Primarily the housing associations that we worked with. In Paisley, we worked with Williamsborough Housing Association. They provided 3 tenement solid sandstone. And we also worked with Castle Rock, Edinburgh. In Edinburgh, they provide 1 basement tenement building. And also later on in last year, with Hillcrest Housing Association in Forfar in Angus, and they were able to give us 6 dwellings, semi-detached, 1-storey bungalows, which was great. And ourselves as researchers, testers, and main authors of the document and the outputs. In terms of the case studies, we're talking about these 10 properties spread around central belt of Scotland and also over in Forfar. And for example, in Paisley, we've got 3 tenements. In Edinburgh, just one example there with Castle Rock. We've worked with Castle Rock quite a lot in the past, certainly with Historic Environment Scotland. And some really nice bungalows with Hillcrest and Forfar. So as we can see, the 4 tenements, very typical of central belt of Scotland. The use of your blonde sandstone, single stone, single wall, where we've got the ashlar facing, this very fine kind of quarried, good quality sandstone, and behind it a kind of rubble wall, very rough kind of wall behind that. We also had an example of your typical kind of west stone, the red sandstone, very similar with the ashlar at front and rubble at back. But then the Forfar houses, the bungalows, were very interesting as well, very kind of particular designs and also particular kind of residents within them. A very nice red sandstone as well. Very kind of ornate and very interesting as well, but very poorly efficient. The kind of the common aspect within all these 10 properties was that they were performing badly. The residents were uncomfortable and were spending a lot of money for heating these properties. The tenement buildings were 3 of them were unoccupied and underwent a great deal of intervention in terms of retrofit. 1 of them was occupied, the one in Edinburgh, and the 6 in Forfar were all occupied so really it was dealing with the social and also the kind of availability and access to these properties. So in terms of the results and some of the kind of testing that we underwent, what we prioritize in these projects is to perform a pre and post intervention testing. And it's really important for us to just like Barbara was explaining, to understand the baseline, to understand the way that the properties are operating to begin with, to use that as our kind of figure to improve, and then any other interventions, making sure that we understand the extent of them and also understand what these post-testing and post-monitoring was to really get an appreciation of the improvement if possible. So we used 3 different tests. We used air tightness, air permeability testing with our blower door tests into each property. We also used in situ U-value testing, where we were able to install our heat flow mats for a period of 15 days at pre and post intervention, and to understand a kind of more dynamic U-value, to understand how much heat was escaping through the envelope of the properties. And essentially, here we're trying to measure the impact of the before and after of these beads inside the cavity. The air permeability was really interesting because obviously we had to take an approach of understanding the extent of the retrofit, not just walls, but also later on any other work that had been done by the Housing Association. And finally, looking at the condensation risk analysis. Now, this is part of a lot of the historic environment Scotland testing that we did before. Again, this was limited. It was a very small number of cases. And here we wanted to really understand similarly how this performed. And we were able to put in condensation, temperature and humidity probes into the cavities, and to understand over a period of pre and post how that performed. So on to some of the results. Just kind of want to cover these quickly. But really, the U-value results were really good. At pre-intervention, we had results ranging roughly between 1 and 1.4 watts per meter squared Kelvin. So this, I mean, if we compare it with new build standards, it's much higher than you would expect in a new build. New builds are around your 0.18, 0.20 of watts per meter squared Kelvin, and obviously existing buildings have other thermal properties of the materials. And in this case, they range between 1 and 1.4, which is quite high. So once we were able to inject these beads into the property, into the cavities, we were able to get a reduction down to 0.45, ranging towards 0.6. So that, I mean, overall was actually giving us, within the 10 monitored properties, a 63% reduction. This is a mean average reduction with all the 10 properties, which is quite impressive. We did have some problems in some of the tenements in terms of the heating. One of the requirements for doing the in situ U-value testing is to have a constant temperature difference between the inside and the outside. We had some problems with the heating devices and the boilers, etc. So the robustness of those was not very good. But then in the 6 properties we did in Forfar, the quality was much better controlled. And that kind of mean reduction just reduced us slightly down to 56%, which is still quite high in terms of reduction. The largest improvement came at 83%, and the lowest improvement down by 37%, which is still quite good. But this was always very much related around the depth of the cavity. And that was something that through our surveys, which we conducted every time we entered a new building and a new dwelling, was to recognize how deep that cavity was. Now, a lot of your masonry cavity walls post 1919 range around the kind of 40 to 50 millimeters in depth and thickness. But what we found in these cavities behind the lathid plaster or plasterboard was that they were ranging between 80 and 130 mil. Now, we found that even on the same wall that we were analysing and surveying, that we would get that variance in depth. So maybe in the lower end we would have 80 mil, then a metre up the wall, up to 100 maybe depth, and then maybe varying 130 down to 80 again. So the roughness of the rubble wall behind this lining was very uneven, giving us a variation in cavity depth. So again, that has an impact on the thermal response of any intervention, in this case the beads, where you would have thinner and less beads at one end and more on the other. But we did find that the deeper properties, the deeper cavity, had the largest improvement compared with the lowest, with closer to 80 millimeters. So that was really interesting to look into that through the cavity analysis and a lot of our surveys of the properties. In terms of the air leakage, now it brought us some difficulties, and also some of the results came out of that were really interesting. Again, we did testing at a pre-intervention to get a baseline, and then a post-intervention, and we were able to acquire some reductions primarily in the tenements. So the buildings where we tested in Paisley, and we were able to measure a kind of pre-intervention of 15 meters cubed, and after the interventions were installed, after retesting, we were able to reduce that by 3 meters cubed down to 13. Now, that might seem as very low reduction, but if we look at the grander scope of the building and the type of interventions that were done, just looking at the walls in this case, and just a general kind of improvement of the finishes of the build of that flat, etc., it's a considerable reduction. Now, unfortunately, in the testing that we did in the Forfar properties, which are your 6 dwellings, kind of semi-detached properties, we observed a very low reduction in air permeability. Now, the reason for this was that the beads were only installed in one of the walls, which meant that the retrofit wasn't, as we're talking about today, a deep retrofit. It only looked at one of the walls. Hence why the reduction was very small. Now, if these properties were to go through some of the retrofit that was done in the tenements, I'm sure that reduction would be much grander. But we got a kind of air permeability of 10 down to 10.4 down to 10.3, so really minimal in that sense. But nevertheless, we have seen that from these tenements and this reduction of those is really good. So in terms of the impact and the benefits, just to really wrap up the work that we did, it's really important to really emphasize that this intervention is very easy to undergo. It's one of the benefits is really that speed of install. Once the survey's been done, series of holes are placed within the different heights of the wall, between studs, between noggins, etc., to be able to fully fill that cavity behind. It's not as obtrusive as other kind of interventions like internal wall insulation, where you've really got to create a new frame around an insulation layer. Once the bead is inside and once these holes have been filled, it's really just replastering and filling in those gaps. It's quite cost effective compared with indoor wall insulation, and it's certainly very interesting in the way it can achieve much lower and contribute to lower energy performance certificates. But most importantly, a lot of the good feedback that we've received, especially the Forfar occupants who were right there from the start, is improvement in thermal comfort, improvement in really just being in these in the living rooms and just kind of getting that sense of not having to have the heating on, flow on, and full blast. And obviously that will translate into lower fuel bills and a better in terms of environmental impact as well. So really interesting in how that has an effect. And I think if anyone listening to us today is from social housing, it has and contributes a great deal to the EIS, which Barbara was also aligning to, the social housing kind of energy efficiency targets, and together with other retrofit options like windows and boilers and other kind of aspects, it can really be a good way of achieving lower thermal aspects. We did a quick kind of evaluation looking at energy performance certificates against the before and after, and we did observe up to 3,500 kilowatt hours of energy saving just for space heating, which really translates over to 130 odd pounds in savings and up to 750 kilograms of CO2 per year reduction. So these are kind of just early indications of what the impact could be of property with these beads all out, all the walls with these beads kind of intervened and injected. So really that's just a bit about this case study and how the beads have been great to achieve these benefits to the occupants, to achieve lower energy and to contribute to lower energy bills and environment. And I hope it can be used for new trials and to expand the work. Something that we did just to finalise, find through the condensation risk analysis is that we weren't able to do testing for a longer period, which is really used. We tend to use dew point temperature as our kind of indicator of any humidity building up into these cavities, and that's something that we hope to expand with Energy Store to go through some of the trials and for longer periods of testing to understand different seasons and how humidity can build up, if any. I'm confident through these early tests that won't be the case. But yeah, thank you very much for the opportunity, and please keep in touch for the final kind of report, which will be disseminated soon through the Constructive Scotland Innovation Centre. My details are there if anyone has any questions, but I can also answer some if anyone has at the moment. Thank you very much.
So thank you very much, Julio and Barbara. I can't see that Joanna is able to speak again, so I'm jumping in. My name's Felicity. I manage the Scottish Home Renewable Service at Energy Saving Trust, for those who don't know me. Julio, we'll keep your slide there if that's okay, because that says Q&A on it. I can't see that we've got any questions coming through from the attendees, but if there are questions, please do let us know. I have one question though, given that time is of the essence and we started a bit late today. Our question was, what is deep retrofit and why is it important? We've seen that deep retrofit can be very complicated, that it's about optimizing what you can do with an individual property, and we've talked about some various different measures that can be done. I suppose the question is, if you were a homeowner at the moment, say you'd reached out to Home Energy Scotland, you'd got some advice about what renewable technologies might be suitable for your property, but you want to go a bit further than that, where would you start theoretically? All these projects seem to take a lot of organisation, a lot of different people involved. So what would your advice be to somebody who is interested in doing this kind of thing to their own home? Should we start with Barbara?
Yeah, hi. Yeah, it's an interesting question. All of this, or maybe the case study that I went through, might look complicated and resource demanding, but we really try to adapt to the different circumstances and the different clients and the different needs in terms of not only budget but also time. And we do have a minimum list of things that we would definitely try to do before we recommend how to improve the property. Visiting the property, it's important to us. Trying to run some minimal test. This could be, for example, conducting thermographic surveys, which can be done in a day. That's the minimum thing that we would definitely try to do. I would advise homeowners to contact, if possible, someone who understands building physics, and that's mainly if they are thinking on improving the building fabric, and that means to insulate walls, roof, or ground floors. Because if the person it's not sure of what they're doing, as I mentioned before, they might be introducing new problems or unintended consequences. So I would try to do it with a qualified professional. Past 2035, it's in the process of they are offering through different organizations, they're offering trainings to professionals, and not sure where this list of professionals are, but I'm happy to assess people in the process of finding the most suitable professional. So very welcome to get people can contact me by email, or and I left my contact details in the slide.
Thank you, Barbara. Yeah, we'll get the slides out to everybody afterwards, as well as the recording. Julio, you said that I think 60% of Scottish buildings were built before 1935, if I got that correct at all. That's a big amount of buildings that could undergo some kind of deep retrofit, or some variation of deep retrofit. How possible would it be to address this scale of a challenge?
Yes, it's a big challenge. As you say, a great deal of them are kind of in this category. And sadly, deep retrofit isn't ideal for all properties. Of course, if we had the opportunity to do deep retrofit, we would do it. And I think one of the issues that we face is that these are properties that are still being occupied. And I think back to maybe your question, something that a lot of the occupiers need to understand is obviously the level of retrofit that they want to do, given that different levels will require them to maybe vacate the property, or to kind of move around from room to room while work is being done, etc., etc. So it is a problem that that a lot of people have to kind of look into, to understand that level of retrofit. So I mean, one of the good things about different levels of them, like and interventions, is to really understand that that intensity of the retrofit.
Can I add a comment on that, if it helps?
Sure.
Yeah.
What we try to do when I completely agree with what Julio was saying. I think it is a big challenge. What can be done in the cases where properties are occupied, it's to plan the retrofit strategy in stages. There are many things that can be done externally in first stage. I didn't have time to go through the details of the cross walls, but even in for very deep retrofit projects, there are many things that can be done externally and to minimize disruption to the residents, and plan with a whole house retrofit and a holistic way how to stage these measures for and long terms. But it can be done. Internal measures are disruptive, and mainly if buildings are listed and can be treated externally, deep retrofit can be disruptive, but there are also quick wins. There are also low budget measures that can be introduced, and so it's important to plan a strategy and do it in a holistic way by people who understand the different risks and performance issues.
Brilliant. And this is where somebody like a PAS 2035 retrofit coordinator might come in handy to help with the planning.
Correct.
Brilliant. Thank you both so much. I'm going to end that now because, as you know, we started late. I think just to summarise, this is obviously a great opportunity for people who have the kind of resources where they can undertake this kind of a lengthy and probably quite costly project as well on their home. General approach would be, as you said, start planning, talk to experts, look at case studies, look at quick wins, low-hanging fruit, etc. And in general, use the resources that are available. Home Energy Scotland is a good place to start, but we don't have architects on our staff, so or retrofit coordinators at the moment. So going out to other experts is definitely important there. Thank you all very much for joining. Apologies for technical difficulties again. If you do have questions, please let us know, and we'll answer them as quickly as possible. And Barbara and Julio's contact details were on the slides as well there. Thank you again, and we will send around the recording shortly. Have a good day, everyone. Thank you.
Thank you. Bye-bye.
Bye.